Hey guys, and welcome to Sketching Quadratics Part 2. Now before we start this lesson, I hope you've already seen our introductory lesson, Sketching Quadratics Part 1, and done the practice that I've given you there, so that you have a good base before we get started. We're going to start this lesson with the same example we ended our last lesson with, but then we're going to move on to more complex theory about the shapes of the curve, the roots, the y-intercepts, and that vertex point. And as always, we'll end this lesson with a bit of practice and some answers taken up. So let's get started so I can show you what I mean. So here's my y equals x squared graph, and there's my y equals x squared minus 3. Remember, my y equals x squared graph just touches the x-axis at this one point here, while the y equals x squared minus 3 graph, 3 below the x-axis, so it's not touching the x-axis here, but it is crossing the x-axis in these two places. So how many solutions does it have now? It's got these two solutions, although we can't see exactly what they are. Now, another word for solutions to a quadratic when it's equal to 0 is called its roots, where it touches the ground, you could say. So although in this graph we can see that there are two roots, we can't see exactly what they are. Often you will actually need to solve this quadratic, so either factorizing, using the formula, or completing the square and rearranging to solve. Now what about this quadratic? What's this going to look like? This is related to the y equals x squared graph. With my 3 terms, it's a bit more complicated to just say it's 1 above or 3 below. So we may want to do a table of values and plot some points to see what this really looks like. Here's my table of values. Again, the x values generally in the question, they'll tell you to plot the graph where x is from -3 to 1 in this example, or from -5 to +5. They'll tell you what x values to choose, and you'll find the y values. So when x is equal to -3, we're going to need to substitute that in here. -3 squared, which is 9, plus 2 times -3 is -6, plus 1. So 9 minus 6 plus 1. That's 4. And again, I'm just substituting this value into the equation for x. So -2 squared, which is 4, plus 2 times -2, which is -4, plus 1. So that's going to be 1. So here are the values I find by substituting them in. Now, I could fill in this table of values as I have done, or I could have just looked at the equation and figured out some information without having to do the table of values. The most important information that I need is where it crosses the x-axis, where it crosses the y-axis, what's its shape, and where is its turning point. First of all, we know the shape of the curve. It's going to be a U shape, or a happy face, because it's a positive parabola. That is, the x squared term is positive. The a coefficient will be +1. Where will it cross the y-axis? Well, the y-axis is a line x equals 0. So that's where x equals 0. And if x equals 0, then all I'll have left is the 1, the c term. Now let me show you that for any quadratic, where we've got y equals ax squared plus bx plus c. If x is 0, a times 0 squared will become 0, b times 0 will become 0, and c is the only thing we've got left. When x is equal to 0, y will always be equal to the c term. And finally, where will it cross the x-axis? That is, where are the roots? Well, as we saw, the x-axis is where y is equal to 0. So that would require us to solve this quadratic equal to 0. Now that's the most work that we're going to need to do in order to accurately sketch this quadratic, but we have several methods for solving quadratics. We can either factorize, use the formula, or complete the square and rearrange to solve. So here's the actual graph of y equals x squared plus 2x plus 1. Using our table of values and plotting those points accurately, this is the curve we end up with. But there's no surprises here. When I ask you to sketch this graph, you don't need to use a table of values because you will automatically say, this is a positive parabola, positive U shape. And it crosses the y-axis at +1, because when x is equal to 0, those two terms become 0, and I just have +1. Now, here's the hard bit. How many solutions does it have? Well, since I've accurately graphed this, you can see that there's one solution. Figuring out what that one solution is, if you're lucky it's in the table of values, and it is, When y is equal to 0, x is equal to -1. But just by looking at the equation, you can see we can solve that quadratic by factorizing. X squared plus 2x plus 1, two numbers that multiply to make 1 and add to make 2 are 1 and 1, which means there is one solution because these brackets are the same. This bracket will be equal to 0 when x is -1. Same with this one. So our one and only root is where x is equal to -1. Let's do the same with this quadratic. What's it going to look like? We could go through the process of filling out a table of values, but only if you actually need to graph this accurately. So here's my table of values, and I've chosen some values from x from -5 up to 0. Filling this table of values in, -5 squared plus 5 times -5 plus 6, and -4 squared plus 5 times -4 plus 6, and so on. But I don't need to go through this process if I just want to sketch the graph. Let's see what information we can get just from the formula so that we can sketch the curve without needing to go through all of this process of filling in the table of values, setting up our axes, plotting those points accurately. Not necessary. We can just first look at the formula and say, what's the shape of the curve? Well, my a coefficient, so my x squared term, is positive. That's going to be a positive parabola. That's a U shape or a happy face. Where will it cross the y-axis? It'll cross the y-axis at C. When x is equal to 0, this is 0 plus 0 plus 6. So y will be equal to 6. So I could draw my y-axis in here, but I'm not sure where to draw it. Should I draw it over here and that's 6? Or should I draw it over here and that's 6? Let's see, because it might help if I know where this part of the curve is. Is this part of the curve before or after the y-axis? So where will it cross the x-axis? If I solve this quadratic here, when I set it equal to 0, I can solve it by either the formula, by factorizing, or by completing the square and rearranging. I tried by factorizing because I know two numbers that multiply to make 6 and add to make 5 are 2 and 3. So my two solutions for x, what will make this bracket equal to 0? -2. And what will make that equal to 0? -3. So I've got two real roots, and I know what they are, -2 and -3. So now I know how to draw my x-axis in here. This curve here is going to cross the x-axis in two places, and they're both negative numbers, which means my y-axis should come after that. So this is my y-axis. That's 6. That's -2, and that's -3. Okay, that's that time again. Time to get some practice in. So I want you guys to sketch these 6 quadratics. Some of them are already factorized, which might help you to find the roots, and some of them are already expanded out, which will help you to find your y-intercepts. Before you do your sketch, you need to work out the shape of the quadratic. Is it a positive, so a happy face parabola, or a negative parabola, so a frowny face? Work out the roots, so when will y be equal to 0? That's where it crosses the x-axis. Work out the y-intercept, so when x is equal to 0, what's y? Draw the curve. Draw the x-axis, showing either it crosses the curve in two places, it just touches the curve in one place, or maybe it doesn't cross the curve at all. Draw the y-axis and make sure that you've put your y-axis where x will be equal to 0. So in relation to your two roots or your one root or maybe no roots, make sure that your y-axis is on the correct side of those roots. And label the points of intersection. Label your x-intercepts and your y-intercepts. Now hit pause now if you want a chance to do that, or if you want to see me do the first one first, I'm about to take that one up. Here's number 1. So it's already factorized. I already know my roots. I know that y will be equal to 0 when x is either equal to -7 or +1. But I'm going to expand this out so I can also find my y-intercept. Expanding that out, I can see that when x is equal to 0, y will be equal to -7. And here I can clearly see this is definitely a positive parabola. So I'll draw my curve. I'll draw my x-axis in there, showing that it's going to cross the curve in two places. I'll draw my y-axis in there, and I know that the y-axis actually has to be between my two roots, because one of my roots is -7, and the other root is +1. I've drawn my y-axis closer to the positive 1 than it would be to the negative 7 to show that my y-intercept is not this midpoint here. It's over here closer to this side. And my y-intercept is negative 7. So I'll go ahead and label my intercepts. My roots, negative 7 and positive 1, and my y-intercept, negative 7. Hit pause now if you need a chance to do the other questions. Otherwise, here we keep going, taking it up. Question 2, it's already expanded out. I can see my y-intercept is negative 12, but I'm going to factorize to solve that. Now I can see that my roots are negative 6 and positive 2, and I can go ahead and draw a positive parabola for this. I can show that it's going to cross the x-axis in 2 places. One of those roots is negative and the other one's positive, so my y-axis is going to be in between them, but closer to 2 than negative 6. And I've got my y-intercept, which is negative 12. Labeling that, let's go on to question 3. It's already factorized, so I can find my roots. Y is going to be equal to 0 when either this is 0, so x is going to be negative a half, or when this is 0, when x is positive 4. But expanding that out, I can see that my y-intercept is going to be negative 4, and I can go ahead and draw a positive parabola that's crossing the x-axis in 2 places. One of those places is negative and the other one's positive, so the y-axis is in between them. And my y-intercept is negative 4, so let's label that all on there. Question 4, it's already expanded out. I can see my y-intercept, it's positive 1. If I factorize, I can find my roots, and look at that, it's a perfect square, which means it's got one root right in the middle, and it's going to be at when x is equal to positive 1. I'll draw my positive parabola. I can see that it touches the x-axis in just that one place. I'll draw my y-axis on there, and the y-axis is where x is equal to 0. My root is where x is equal to positive 1, so the y-axis has got to be to the left of that. And my y-intercept is positive 1, so I'll label that on there. Question 5. Now this one looks like a difficult one to solve, but in this format I can clearly see my y-intercept is negative 20. To factorize this, notice there is a common factor, so you didn't need to split the middle term. Now looking at that quadratic, I can factorize that again. Multiplies to make negative 10 and adds to make positive 3 are 5 and negative 2. From this format, I can find my roots. That's when x is equal to negative 5 or x is equal to positive 2. So I'll draw my positive parabola. I have 2 roots. One of them's negative and one of them's positive, so the y-axis is going to be somewhere in between, closer to the 2 than it is to the negative 5. And my y-intercept is negative 20. So I'll label my crossing points. Last one, question 6. Now this one is a bit of a tricky one. Looking at it like this, we can see our roots are 2 and 7, both positive roots. But if you expand it out, and if you do this correctly, you'll see that we've got a negative parabola this time, because we've got negative x times positive x makes a negative x squared term. So I'm going to draw a negative parabola. It still crosses the x-axis in 2 places. Once when x is 2 and once when x is 7. Both of those are positive numbers, so my y-axis needs to be to the left of that. And my y-intercept is negative 14, so it makes sense that it's crossing way down below the x-axis. Let's label our intersecting points on there. Okay, if you had any trouble with this, please send me a message. Otherwise, I think we're ready to move on to our last lesson, Sketching Quadratics Part 3, where we'll start looking at completing the square and finding what that vertex point is, that point that's at the maximum, or in the case of a positive parabola, a minimum, right in the center of symmetry of the parabola. See you next time.